When your motors are equipped with the integrated encoders, the VEX Cortex can automatically adjust the motor power levels so that its wheels move at the specified speed, rather than just being driven with the same power. This is very important if you want your robot to drive straight, and is much simpler than the automatic straightening algorithm we implemented using the shaft encoders. This ability, known as PID speed control, uses the integrated encoders to detect how much each motor has spun. By comparing the motor's current position to its position a split second ago, the robot can calculate how fast the motor is moving. If the motor's actual speed is lower than it should be, the PID algorithm will increase its power level. If the motor is ahead, PID will slow it down. Here's how it works. The robot starts with a goal, the desired speed specified by the programmer in the program. Now, if your motors were perfect, ideal motors, all you would need to do is set the power of the motor to match the desired speed, and that would be that. Real motors very rarely match up perfectly with ideal motors. Using the same power level, a real motor will achieve a slightly different speed, usually a little slower than the desired speed, due to the effects of friction on the motor and the wheel. The difference between the desired speed and the actual speed of the motor is called the error. This is the difference in speeds the robot needs to adjust for. By looking at the error, the robot has some idea of what kind of adjustment it needs to make to the power in order to get the speeds to match. The PID algorithm looks at the size of the error, as well as how the error is changing over time, and calculates an adjustment to make to the base motor power. This adjustment value is added onto the power, and the cycle repeats. The motor now runs with the adjusted power level, and its speed is measured. Its speed is compared against the desired speed, and a new error term is calculated. The error is fed to the PID algorithm, which calculates further adjustments. The adjustment is applied to the motor power and repeat. This setup, where the robot monitors and adjusts its speed based on measurements it takes itself, is called closed-loop control. The term refers to the fact that the adjustment process is self-contained, or closed. No outside input is required. PID gives your robot the ability to intelligently self-adjust its motor power levels to the correct values to maintain a desired speed. The closed-loop system monitors the error difference between how fast the robot is going and how fast it should be, and makes adjustments to the motor's power level accordingly.